So solving an equation that can be written in quadratic form, problem type 1. I have two different examples in this video that I'm going to show you, and the key is for all of these problems, it can be written like a quadratic equation, meaning you can try to write these problems in the form of like x squared plus bx plus c equals 0, and then try to factor. Okay, or it might even be something with a leading coefficient that's greater than 1. It could be ax squared plus bx plus c equals 0, and then you have to try to factor. But for all of these, they will and can be factored. They just look super scary because, I mean, look at that. That looks like super hard to understand. Now, the trick is, especially for a problem like this, is to see the pattern in the term. So like what I'm noticing here is I'm squaring x squared minus 11 to start, and I'm doing negative 10 times the same thing, x squared minus 11. So let's try to do this. I'm gonna, to make this look similar, let's let p, I'm just picking any letter, could be anything you want, I'm just letting p be equal to this expression x squared minus 11, just for a second. So if I rewrite this, instead of x squared minus 11 squared, I can just say that's p squared. Then this is going to be minus 10p plus 25 equals 0. Now that looks a whole lot more reasonable to try to factor. So two numbers that multiply to positive 25 and add to negative 10 is negative 5 and negative 5. This is actually a perfect square trinomial. Square root of p squared is p. Square root of 25 is 5. Put a negative here. So it's p minus 5 quantity squared equal to 0. So what I would do, I'm going to continue to just solve this. So if it's p minus 5 squared equals 0, that means p minus 5 has to be 0. So that means p is 5. Now don't think you're done. Because we know p is 5, we didn't answer this equation. I'm going to go back to what I said here. P is really x squared minus 11. So instead of p equals 5, it's x squared minus 11 equals 5. So I'm substituting back my original expression now that I have kind of this thing solved. So I'm going to add 11 to both sides, and I get x squared equals to 16, and now I can solve by square rooting, and I get x equals plus or minus 4. So my solutions would be 4 and negative 4 for this problem. So the nifty trick, I think, all lied in doing this. Similarly, it's kind of hard to say. Maybe not. Maybe it's just too early in the morning. Okay. Solving an equation that can be written in quadratic form, problem type 1. Here's another one. Doesn't look quite as crazy, but you might notice this is not really a quadratic, right? It's raised to the 4th power here. Well, the key is you want to write this as a quadratic. So for this problem, I would think of, again, I'm just going to use p since I did it before. Let's let p be equal to y squared. So I can rewrite this. This is the same as y squared squared, right? That's y to the 4th. Minus 17y squared plus 16 equals 0. I'm rewriting it like that so you can see I have this y squared that pops up twice, so I can kind of, I'm going to replace that with a p again. So it's like p squared instead of y squared. So I'm going to write p squared minus 17p, because remember, p is y squared. I'm just using substitution, plus 16 equal to 0. I've just rewritten this as a quadratic equation. And now I'm going to try to factor it. Two numbers that multiply to be positive 16 that add to negative 17 would be negative 16 times negative 1, right? So if I FOIL this out, I would get this back. Well, if I set p minus 16 equal to 0, that means p is 16, and if I set p minus 1 equal to 0, I get p equals 1. Well, again, you need to remember we're not trying to find what p is equal to. We want to know what y is. So we got to go back to what p is. It's y squared. So instead of p equals 16, I'm going to say y squared equals 16. And if I square root, I can get y equals plus or minus 4. Then p is equal to 1. So I had p equal 1. That's really y squared equals 1, right? And so if I square root that guy, I get y equals plus or minus the square root of 1, 1. So my answers would be like -4, 4, 1, -1 are my answers. So I hope this helps. Good luck.